Today we're talking about domain and range. This might be the first time you've heard these words, so let's start with some definitions. Domain is the set of all x values that are part of the solution set to a relation or a function. And the range, similarly, is the set of all the y values that are part of the solution set to a relation or a function. The most simple way to look at this is to start with discrete relations. Remember, discrete relations are those with distinct points that are not connected. So let's take a look at these discrete relations and try to find the domain and the range. So the first thing I want to do, since I'm looking for the set of all of the x values, is I want to write down what I'm telling you. I'm telling you all of the x values are equal to this. I'm going to give you not one x value, but an entire set. So I'm going to use this curly brace, which is also called a set brace, because I'm about to give you a set of data. Okay, so I'm going to look at the lowest x value that is a solution to this relation. So I want to look to the left, because we know the lower x values are on the left side of the x-axis. This point right here is the point -6, 2. So that's going to give me one value, -6, that's in my domain. This point right here is -3, 2. I'm going to keep listing these points in order. So this one is -1, -3, +1, -3. Up here I have 3, 1, 2, 3, 4, 5 on the y-axis. And finally I have 4, 5, 6, -1. So I just need to take all of these x values, and I like to do it in order, and list them so that I can express my domain. So we started with -6, and then we have -3, -1, +1, 3, and +6. This is the set of all of the x values that are parts of the solutions to this relation. Now let's look at the range values. Again, I need to tell you what I'm telling you. I'm giving you the range, so I'm telling you here are all my y values, and it's going to be a set of numbers, so I'll put it in set braces. So I go right back to my ordered pairs now, and now I'm just going to pick out the y values, starting with the lowest y values. So let's start from the bottom and go up. So my lowest y value here and here is -3. I don't need to list it twice. -3 is part of the solution, part of the range, so I only need to list it once. -3, and then we have -1, and then we have +2. Again, I have two +2s. I only need to list them once, and +5. These are all of the y values that are parts of the solutions to this relation. Now I'd like you to pause the video and see if you can do the same thing. See if you can describe the domain and the range of this discrete function. And when you're through, play the video and come on back and see how you did. Okay, so check your work. I've listed all of the solution points, and in the domain I've listed all of the x values, and in the range all of the y values. Something that's important to keep in mind when you're talking about domain and range is that it's standard to list the values in order from least to greatest, and it's also standard to not repeat any repeated values. So again, you only need one copy if the value has been repeated. Finding the domain and range of discrete functions is pretty elementary. We find all of the solution points, their x and y values, and then we pick out all of the x values for the domain and all of the y values for the range. But when we have a non-discrete function or relation, for example, like continuous relations where all of the solution points are connected with a line or a curve, it becomes a little bit more complicated. So let's talk about notation for a moment. So below here we have two continuous functions. Notice that here we have a closed circle on the end of this graph. Whoops, I'm not writing. Here we go. We have a closed circle on one end and an open circle on the other. What this closed circle means is, hey, this is a part of the solution set to this graph. And what this open circle means is that it is not included in the solution set to the graph. Think of this open circle as being a hole in the graph. So this point at 1, 2, 3, 4, 5, 5, 4 is actually not included in the solution set to our graph. On the other hand, we can have arrows on one end of our graph. And what that means is that the solution set is going to keep going in that direction endlessly toward positive or negative infinity, whichever way it's pointing. So these first two types of endpoints, the closed circle and the open circle, actually put boundaries on the solution set to our function, whereas the arrow does not put a boundary on the solution set. And we can have any combination of these three different types of endpoints. We can have two closed circles, we can have two open circles, we can have a closed circle and an open circle, or a closed circle and an arrow, an open circle and an arrow, or we can have two arrows. And we're going to look at some of these options in the next graphs. So let's get started and look at the first set of graphs here. So remember, we're looking for the domain, the set of all the x values, and the x-axis goes from the left to the right. So I'm looking for my left to right boundaries. Are there any boundaries being placed on the solution set shown in this graph? So yeah, my point farthest to the left is right here, and farthest to the right is right here. So all of my x values have to fall between those two lines. It looks like 1, 2, 3, 4, negative 5. This is x is negative 5. And 1, 2, 3, 4, 5, 6, positive 6 are the boundary markers. So all of the solutions to this function can be found between the x values, negative 3, and positive 6. Now, I didn't put my inequality symbols in there yet because I want to look at the endpoints. This is a closed circle, meaning the x value of negative 3 is included. So not only are my x values greater than negative 3, but they can also include negative 3. And the same thing with 6. So x is going to be less than or equal to that value of 6. And for the range, we'll do the same thing. But remember, range is all of our y values, and that goes up and down. So we're looking at any upper or lower limits to our graph. So I'm going to try to finish drawing a box around this graph. I have two vertical uprights, and now I'm going to draw two horizontal lines that put boundaries on my solution set. Here's my lower boundary, and here's my upper boundary. What are the y values here? This is y equals 2. And this is y equals 5. Again, I want to look at my endpoints, and I'm dealing with the same endpoints. That's not always the case between domain and range, but in this case it is. And both of them are solid circles, closed circles. So that means that these values of y equals 2 and y equals 5 are in fact included in the solution set. So they're also included in my range. So my lower y value is 2. And my upper y value is 5. So all the y values in this graph fall between 2 and 5 included. Let's keep going and look at another example. So here we have another continuous graph. And notice that we are bounded on the left and right. So when we're talking about the domain, that will be helpful. We're talking about all the x values. So let's draw out those boundary lines that constrain the solution set of this function. So this is x equals 0, and this is 1, 2, 3, 4, 5, 6. X equals 6. All right. So notice that this time we have open circles on both ends of this graph. So that means this value where x equals 0, that is not included in the solution set. And this value where x equals 6 is not either. So they're not included in the domain of the function either. So the only difference, we still have, we'll still set our boundaries at 0 and 6, and we still have x. All of our x values are somewhere in between, but this time we won't have an equal sign on the bottom of our inequality symbol. The x values can be between 0 and 6, but they don't include 0 and 6. And it's going to be similar for the range. So let's take a look at that. Remember, we need to draw our lower. We're talking about up and down now on the y-axis. The y-axis goes up and down. So here's my lower boundary, and that's at y equals -2. And here is my upper boundary, and that's at 1, 2, 3, 4. Y equals 4. I'm going to draw that over here. Y equals 4. Okay. Oh, I need to do some erasing here, don't I? All right. So that was -2. All right. So my range has a lower bound of -2, an upper bound of +4. So -2, my y is in the middle, +4. Again, I have open circles down here and up here. So this y value of -2 is not included, so I will use a less than operator, and same thing with 4. So all my y values can be between -2 and +4, but they don't include -2 and +4. I want to do some erasing here and just really emphasize the fact that we are drawing a box. To the extent that we can, we want to draw a box to show the boundaries, to show where is this function bounded. When we have arrows, we can't draw all of the box, but when we have solid or open circle endpoints, we can do that, and we can show all of the boundaries on our functions. All right, we're going to keep going and look at one that's just a little bit different. Okay, so here we have, in this graph, we have that situation where we've mixed up an open circle and a closed circle. So starting again with our domain, we're looking from left to right. What are the left and right boundaries? Here's our lower bound, and here's our upper bound. What are those x values? This is x equals 1, 2, 3, 4, 5. X equals 5. Okay, so all of my x values can exist anywhere in between here. So I've got lower bound 1, upper bound 5. My x's are in the middle. Notice this one is an open circle. So the value of x equals 1 is not included in the solution set. So here, I'll just use a less than. Or x is greater than, but does not include the value of 1. And here I have a closed circle. So x can take on a value of 5. So x can be less than, or it can be equal to 5. And how's that going to work with our range? So let's keep drawing our box. We're looking for our lower bound. I'm already seeing that our lower bound is not going to be included, and our upper bound, closed circle, is going to be included. What are these y values? So lower bound is 1, 2, 3, 4, 5, 6, -7. Y equals -7. And this upper bound is y equals 0. It's right on the x-axis. Okay, so I've got -7. Y's are in the middle, 0's out here. All right, the lower bound is not included because I have an open circle, and the upper bound is included. So we'll have a less than or equal to. All my y values have to be greater than -7 and less than or equal to 0. Now I have a crazy one for you. Okay, this one's a little bit different, so keep your eyes peeled. Okay, domain. We're going to draw that box. Draw the box. The box will help you. So our left boundary, because we're talking about domain, we're talking about the left bound and the right bound. Or lower and upper bounds are on the left and on the right. Okay, this is an x value of -1, 2, 3, 4, 5, 6, 7. X equals -7, and 1, 2, 3, 4. X equals 4. Okay, -7 is included, so -7. Y values have to be greater than or equal to -7, and I'm sorry, those are x values, aren't they? X values. And x equals 4 is not included in the solution set, so we'll just have a less than 4. Right? All of our x values are all the values between -7 and +4. Can take on any value. And there are an infinite number of x values in between those 2 points. That's an important thing to keep in mind. let's look at the range. Here's where it gets a little bit tricky. All right, we're drawing the lower bound. So despite the fact that this is an endpoint and this is an endpoint, neither of them are actually the lesser, or neither of them are the least y value or the greatest y value. When we draw a box, we'll illustrate that very clearly. So here's the lowest part of my graph. Remember, your box has to include your graph inside it. And here's my upper bound. So these endpoints say that the graph is going through this point or not going through this point, but so does the line of the graph. Remember, this line is where all of the solution points to the function lie. So you can think of if the line is there, you can think of it as a closed circle. All right, so what are these values at our upper and lower bounds? Negative 1, 2, 3, 4, y equals negative 4, and 1, 2, 3, 4, 5, 6, 7, y equals positive 7. All right, but as I mentioned, the line of the graph goes through these values. So these are included. So we're talking about using the equal sign on the bottom of our inequality operator. So negative 4 less than or equal to y, less than or equal to positive 7. So that one's a little bit tricky. Use the box. And finally, we're going to take a look at some that have arrows on them. And these are fun. Okay, we're looking for the domain of this function. So I'm going to do this in blue because we've been doing all of our domain in blue. All right, where is the left boundary or the lower boundary on this graph? It's right here. And can I draw an arrow? Is there a boundary on the right? Is there an upper boundary? What does my endpoint look like over here? It's an arrow. That means that this graph is just going to keep on going. Not only is it going down, but it's also creeping a little bit to the right. So I can't correctly draw a boundary here. It doesn't exist. So the graph is unbounded on the right. So what do I know? I have this one boundary line at x equals negative 1, 2, 3, 4, 5. X equals negative 5. So all I know is that my x values start here at negative 5, and they are greater than negative 5. And that's all I can say. So all of my x values are greater than, but not equal to, negative 5. That's my domain. All right, let's talk about the range, but let's clean this up just a little bit so we can see what we're talking about here. All right, so range. What other lines can I draw for my box? It looks like I have an upper boundary here, and that's at y equals 1, 2, 3, 4, 5, 6, 7, 8. Y equals 8. Once again, I can't draw a lower boundary down here. Can't be done because this line is just going to keep on going down to all of the y values that head toward negative infinity. So I'm going to undraw this line because it's not correct. So that means that my y values are all less than this y equals 8. So y is less than and does not include 8. Okay, we have one more, and this one looks really crazy. Okay, remember, it's easy when you just think about the domain is the set of all x values, and the range is the set of all y values. So how are those x and y values being constrained? All right, so my x values, remember, are from the left to the right. So it looks like I sort of have a boundary over here, but wait a second. This line is going up. But as it goes up, it's also going to the left. So over here, I have the same thing going on. This line is going up, and it's also going to the left. So think about this just expanding forever. And as it goes mostly up, but sort of a little bit to the left, won't it eventually cover all of the numbers toward positive infinity and all of the numbers toward negative infinity? So let's clean this up. Yes, it will. So because we have arrows on both sides here, we can't draw a left or a right boundary. And we can't say that x is being constrained at all. X could be any number along the entire x-axis. So what does that mean for our domain? X can take on any number, or any number that we've learned about in the set of real numbers. So X, or the domain, is the set of all real numbers. And we'll draw it like this, a double stem on the capital letter R. Make sure you've got the double stem. Okay, so that's true for the domain. What about the range? What's happening with the range? Okay, can I draw a lower limit on this graph? It looks like I can. Looks like my graph goes through y equals -3, and it doesn't go any further than that, any further down. Y equals -3. But again, we have these arrows up here. So when I'm talking about an upper bound, I can't draw a line here, can I? Those arrows are going to pass right through it, and so that line doesn't really mean anything. There is no upper bound on this graph or on this function. So all I do know is that y is going to be all of these numbers here above -3 or greater than -3. Is -3 included? I don't have a closed circle or an open circle, but my line does, the graph actually does go through this value. So it is included in the solution set. So what does that mean? That means y is going to be greater than, or it can be equal to, -3. We've looked at a lot of examples here. One example that we didn't look at, and I want to challenge you to find, is a function whose domain and range are both all real numbers. Good luck to you, and I will see you in class.